Okay, thanks a lot for waiting. Good day, everyone. I hope that you are doing very well today. Welcome and thanks a lot to join us very much in today's webinar. And my name is Giorgia Rossi, and I am the worldwide sales manager at Gexcel, who is a company which is in the global market of 3D technology solutions since more than 10 years. And I am pretty excited to introduce today's guest, Mr. Muhammad Aizat bin Abdullah, Aizat for friends, from Topcon Positioning Asia, from Malaysia. And I'm pretty excited because today, together with Aizat, we will move to one of the Malaysian natural paradise, Bio Cave. And Aizat, thank you very much for joining us today. Would you please tell more about yourself, please?
Yeah, thank you, Georgia. Hello, everyone. My name is Muhammad Aizat bin Abdullah. I'm a Regional Deputy Product Manager in Topcon Positioning Asia, Malaysia, Sdn Bhd. And I have been working with Topcon Malaysia for 8 years and handling high-end products such as robotic tool station, GNSS, and 3D data solution, including static laser scanner and also portable laser scanner. Yeah, thank you. So,
thanks a lot.
Yeah. So before we talk about our main topic, I would like to take this opportunity to introduce Topcon Positioning Asia, Malaysia, Sdn Bhd. So Topcon office actually has been in Malaysia for 30 years since March 1991, and it's known as Topcon Instrument Malaysia, Sdn Bhd. So at that time, there were two sections, which is a positioning section and eye care section. And in March 2021, Topcon Positioning Asia, Malaysia, Sdn Bhd was established and act as a regional hub for the South and Southeast Asia under the helm of Topcon Positioning Asia Group. And TPM, Topcon Positioning Malaysia, is dedicated to contribute to develop a South and Southeast Asia region through Topcon unique instrument and technology, mainly in the field of geo-positioning, eye construction, and smart agriculture. So that is some information that I'd like to share to you.
Thanks a lot, Aizat, for introducing Topcon Positioning Malaysia, and we have started to work together several years ago. And what's best is that our common partnership has grown up, and I think I can say also following the common technology developments. And as you know, Gexcel is involved in the global market of 3D surveying and 3D mapping for around 15 years by developing and providing innovative point cloud processing software and surveying systems. So I feel that this is the reason why we have worked and grow up together. Before we get started, just a few information about how you can interact with us today. Please note that your audio will stream through your PC, laptop speakers, and so be sure to check your speakers to ensure that they are turned on. I hope that you are hearing us well, and also that you are looking, that you can see us, okay? If you have any technical difficulties, try to refresh your screen, or perhaps also changing the browser could be useful. Don't worry if you are scared to lose part of the webinar, because this webinar will be recorded for your reference, and you will receive the record by email in the next days. At the end of the webinar, Aizat and me, we will be at your fully disposal in case of a question, curiosity, doubt. In case we might not be able to reply to all your questions, please apologize us in advance. But don't worry, because you can always contact us by email or afterwards, and we will try to follow up as best as we can. So now let's move through today's agenda. Just to give you an idea about how we will spend together the next 30 minutes. After a brief introduction of the success case, we will focus on needs and goals, and we will move to the technology used, and we will enter also in the core of the webinar, which is the workflow that Aizat will describe, the workflow that has been carried on site and also in the post-processing phase. So Aizat will describe what's gone on site, underlining the technology used and also the result achieved. And of course, we will try also to save some time for the Q&A session. So I don't want to waste other time. So now let's move to Malaysia. And Aizat, can you please describe where we are?
Okay, okay, everyone. So today, I would like to share about the Bhd Cave expedition. So as you know, Bhd Cave is situated in Kenyir Lake, Hulu Terengganu, at the eastern of Peninsula Malaysia. So to be more specific, it is located at the bottom of the Kenyir Lake. Okay, you can see from the picture. It is take 2 hours drive from Kuala Terengganu to Kenyir Lake, where the research center on the top there is a research center UMT, is under University Malaysia Terengganu as our base, and from there it took about 45 minutes to reach the Bhd Cave by using a speedy boat. And I like to share a nice fact that from Kenyir Lake is for all of you, that Kenyir Lake is an artificial lake created in 1985 by the Kenyir Lake Dam on the Kenyir Lake River. So it is the largest man-made lake in mainland Southeast Asia with an area of 260,000 hectares. Okay. Besides, it's a nice fact for the Bhd Cave, and it is itself taken from his own location. Is situated on the Bhd Hill, and of course, Bhd Cave is provide a spectacular sight of towering limestone hills. So yeah, thank you for this slide. So Georgia, you can go on for the next slide. Okay, so let me share short detail about the Bhd Cave. Okay, Bhd Cave, also known as a limestone cave, provide a spectacular sight of towering limestone hill. The secret and mysterious of the Bhd Cave still to be explored, and it is believed that the cave has value of history when some archaeologists from a national museum had discovered the skeleton of Neolithic man. And among the artifacts found in 1970s were kitchen utensils, eggs, and tools, nice structure with the magnolia site of the stalactite and stalagmites. So yeah, that's from this slide. You can go on for the next slide.
Yeah, thank you very much, Aizat. It's really fantastic. And at the beginning, I said that today we would have moved to a paradise, and it's really a paradise, but it's a sort of, it's a paradise, but it's a complex paradise, because here we are talking about history, geography, structural behavior, geology, and I think that all of these components are strictly connected one to each other. And when you described to me this project, I have understood why different actors has been called to work together So, which have been, apart from you, Topcon Positioning Asia, Malaysia, the actors involved in this project?
Okay. This expedition was joint organized by local university and government sector, which focused on the mineral and the structure of the cave. Both parties actually have made a memorandum of understanding for their geology study and research in Kenyir Lake. And actually, Bewa Cave is one of the part of the Geopark program, which is University Malaysia Terengganu as one of the scientific committee of the Geopark program. So with technology that we have, they see that it is good opportunity to implement this kind of technology in their research. And for this one, we already collaborate with them and to make it a successful program. Yeah. Thank you.
Oh, so many thanks for this explanation, because I think that is also important to explain, of course, all the actors which have been involved, and this is what I really like more, the collaboration of different entities, different actors for a common goal. Even I think that here the goals are more than one, right? Can you give us some more information about the needs and the goals of this project?
Okay, for this expedition, one of the objectives is to study the effectiveness of using lidar technology in the cave mapping application, and of course, it is to analyze the endogenic cave passage geomorphologies, structure, and morphologies, and of course, is to study a geo-visualization and potential of the cave part of documentation. And this kind of cartology information provide a possibility to extract a vertical and transversal section that are important to support for the execution planning and in an underground environment. And in additional, the ability to calculate the area and volume offer significance and interest prospect in a term of monitoring and within a context of in which conformation of environment may be changed over time. And it is subject of a strategy aimed to improving and promoting tourism in this area. And in this project, 3D laser scanner scan of some of more easy accessible cave room were needed to create multimedia products such as movie, images, scene of 3D visualized tour, and to generate the geocartographic product for tourism excursions. Yeah.
Thanks. Thanks, Isaac, for this for the description of the goals, which are pretty different and many goals. And so we can say that in a certain way, the aim of this project has been double: mapping and monitoring, of course. And of course, for this reason, 3D integrated mapping approach sounds the best way of carrying on the activity. But why has been strategic to use a SLAM solution in this type of survey?
Yes, of course, there's many benefit and advantage for using a 3D mapping, 3D laser scanner in mapping application. If you compare with the conventional method, one of the benefit is a fast data collection at site. So due to the surface of the wall is in the cave, which is a very complex structure, it is save a lot of time to map the cave by using a lidar technology. So where is it capable to collect several thousand to million of points per second have taken over from the traditional methods. So 3D laser scanning technology can increase safety and reduce the risk of the falling, where we do not need to climb or use measuring tape to measure the height of surface. So not even that, we also no need to go to the extremely dangerous surface area to avoid slipping. Okay, and besides, it is very important to have a good result after the data collection was done. By using the 3D laser scanner, the result can be achieved up to millimeter accuracy, where we have confident to extract the information from the data. And last point from the about the benefits, we can gain more information such as visualization by delivering cave in their true 3D geometry at unprecedented level accuracy, create multiple multimedia products such as movie, images, scene, and 3D visual tour. And yeah, that's you can also do many analysis can be done by using 3D point cloud data for this application. Yes.
Yeah, many thanks, Isaac. In fact, I remind that we also discuss about the possibility to use this 3D project also for further analysis like geological analysis, geotechnical analysis, structural analysis of the cave. That, of course, it's a discussion that can be extended also to other industry field. Just going back to the technology used, can you briefly describe the instrument that you used, trying to underline the strength of the device?
So for this data collection, we actually using two different technology. One is the HERON MS TWIN, which is a backpack solution, and a Topcon GLS is a geodetic laser scanner 2200, which is a terrestrial laser scanner. So both devices have their own unique features. And for the HERON, this is a portable system where it is easy to use and compact and confined. And also you can see a real-time visualization. No need to close. The important is no need to close do the closed loop with the high functional pattern algorithm, especially for the fields and post-processing software. So okay, same goes to the GLS 2200. You can do tidy up with the control point by using a resection method or occupied and traverse bedside method, and of course easy and intuitive onboard control software, and the data can be achieved until up to 1 millimeter by using the Topcon magnetic color software. Yeah.
Thank you very much, and I leave you also explain a bit more about the site on these pictures.
Yeah, I like to share to all of you that this is a few pictures that from during data collection at site. So almost all the surface have a unique structure and unique surface. Okay, for static laser scanner, of course, if you use a static laser scanner, you must planning to set up a scan station at every location. Is very important to for you to plan, and of course to avoid missing data. And while using HERON, okay, you can see there's two guys wearing the HERON backpack HERON. They would just walk through the pedestrian area provided to do the data collection. At the same time, we can see the real-time visualization in the controller to make sure we cover all the structure area and all the cave area. Yeah.
Many thanks, Isaac. And let me just ask about this continuous control that can be carried on with HERON, because of course what is nice and also what can be one of the aim of this project is that is the possibility to keep in a certain way under control the site, because what HERON also enables is the possibility to allows to do or to carry on is a sort of control during the time. So after making this first survey, this survey can be used as a sort of reference in time, and in case you would like to update the status of the site or checking for some change and so on in time, you can do that, because HERON can track its position in the reference survey that you have done with the GLS, for example, and you can display in real time also the differences. Just to add also this additional capability that we mentioned at the beginning in terms of mapping and also of a certain way of updating the information of the site. I will jump also to this slide, because I think that you also have used HERON pole-based, right? Not only backpack-based.
Yes. So this is a pole that we use also during the data collection. So to actually this one is you can easily to reach all the small cavity to generate a complete and detailed 3D model. As you can see that this pole actually the pole is tied up with lidar sensor to cover all the complex area. So with this we have nothing to worry about if there's no missed data at site.
Yeah, many thanks. I think that also it's an important aspect that underlines the HERON versatility, especially when you have to work in a hard environment, because you can dismount the capture head and you can use this extensible pole. And what is nice is that you can use HERON in a straight position, but of course you can use it upside down, as we are looking at these pictures in which we put HERON in a sewage, or for example also in cavity. So the versatility of HERON is also in this, in the possibility to cover some parts that could be of difficult, that could be difficult in terms of accessibility. So thanks for giving us also this this view of the HERON usage. I will let you explain a little bit more about the workflow that you have used from the site up to the export of the deliverables.
Okay, thank you, Georgia. So this is the schematic workflow that we have been used for this scanning. So at on-site, we use two, as you know, we use two different technology. One is GLS-2200 and also the HERON MS TWIN. And we use Magnet Collage software to process the GLS data, okay, and also HERON desktop to process the HERON MS TWIN data. So this raw data processes is include the registration for the cloud, and of course trajectory building processing to generate a point cloud for every data, and from then from there, after we generate it, then we can go to the point. We use a point cloud management, which is Reconstructor software, where this software mainly to extract all the information from the 3D point cloud data, such as a 3D mesh. You can generate a contour, you can generate a cross section, you can calculate the volume. So, and then finally we go to this software we can share to cloud sharing, which is we have a Magnet Collage web. Okay, so is a cloud-based system, so you can share to others client or to easily to show the result and easy to deliver the data to all the involved with this project. Yeah.
Many thanks, Isaac, for this description of the workflow. And let me add that with the GLS and with HERON, you can work wherever you like, because the software, the HERON software, are on premise, and so there's no need to upload the data on the cloud to run the process of the data themselves. And as you know better than me, these procedures of uploading data always create a lot of troubles. And so in this way, you are totally comfy to elaborate the data also on site.
Yeah.
Let's jump back to our cave. And Isaac, can you please tell us more about the survey that has been carried on with by the GLS? Some more information.
Okay. For all of you, this is the point cloud is generated from the GLS-2200. So you can see there's a different color represent a different scan station, and you can see there's an orange dot there, the circle dot, which means is the a scan position, scan data, scan station, and to cover all the cave, we set up 26 scan station, where 8 minutes needed for every scan setup. And overall, in total, we took 4 hours at site to cover all the cave area. And after that, we used the cloud-to-cloud method registration in Manat Collage software. It took another 4 hours to complete all the data and generate in the 3D point cloud. So yeah, this is what we have done in 1 day at the Bewak Cave.
Many thanks, and we can let's see if the movie start. Okay, here we are.
Yeah, you can see this is the video fly-through video about the from the GLS-2200 data, and this is in inclination color mode, so you can see easily better visualization to see, because in the cave is a very dark. So actually for this data, you can change to the colorization mode, colorization point cloud data. You can open in RGB images. Okay, so this is the overall of the fly-through video for the Bewak Cave.
Yeah, many thanks. Let me see if we can move to the next slide. Yes, thanks for explaining how does it work, the GLS, also from the post-processing point of view. And can you also give us some information about the HERON survey? For example, how long did you work? How did you work? And just few information.
Yeah, this is I like to show this HERON MS TWIN data, the collection and the point cloud. As you can see, the green line actually is a trajectory data, where we are starting moving from the right to the left side. Okay, and there's a few blue dot, which is indicate the 3D 360 images, panoramic images, so you can view the data later we will show you. So by using a backpack system, we managed to take around 30 minutes duration to do data collection, and we do the processing, and it took us about 1.5 hours to generate a point cloud data after we done the data collection. So this is the visualize and also the result after we process. Yep. As you can see there. Yeah.
I just started the movie also in which you are walking, showing you are walking in the. I just ran it. I mean, you at work in the cave, and also this movie which show what you display when you are moving with HERON. So while you are moving in the trajectory, they are pretty fast, but don't worry, because later we can provide this movie to the attendees so they can experience more about what has carried on site and in the post-processing. Thanks for explaining how did you work with the GLS and the HERON on site. And just to show some view of the cave, in this slide you can see the inner part of the cave, in which there is this path that has been done by walking and also using the GLS static laser scanner. And here you can visualize a part of the indoor cave in which there is the trajectory that has been done by walking using HERON, as Aizat explained, and the blue dot that we have seen before are the place in which the 5K panorama pictures has been taken, because HERON support two ways of images capturing, which are in full HD in real time, and also on demand in 5K. So you have both the information in terms of pictures, and of course you can use both of them to colorize your point cloud. This is how the navigation of the 3D project looks like, in which you can navigate both in the GLS and in the HERON data. And I like it because you have this plan view in which you can follow up the trajectory that has been done on site to visualize the 3D, but also apart from the 3D, you can visualize in details the point cloud with different layer colors, for example, to underline, as Aizat explained before, some features which could be, I don't know, the cracks or some damages or something that you would like to underline. Or you can, of course, also navigate into the panorama pictures. The panorama pictures are automatically overlap onto the point cloud, and so you can navigate in both, in the point cloud and in the panel, taking pictures and taking measurement and extracting different kind of information. Of course, as we have seen also from the movie in which Aizat were scanning the cave, these underground fields are pretty hard, and especially in some cases they are not easy place to work, also for the accessibility. And so HERON can be equipped by different kind of accessory, like for example light, which can help you in moving around, taking pictures, pictures that, as we have said before, are pretty useful for different kind of needs, also in terms of documentation and further analysis. How was possible to put together all the data that have been acquired, the GLS, the HERON? How was possible to create a complete 3D project? and extract then some information that Aizat will describe. That has been possible thanks to Reconstructor, which is a software by which the user can move from start to finish and create all the different deliverables which are needed. And Reconstructor is the market-leading point cloud processing software, and it is composed by different add-ons. In the base modules, you can import your data, filter, automatically register your scan without a target, and thanks to these features, has been possible to merge together the GLS data and the HERON data without any kind of issue or without struggling. And there are also several clouds editing functions that support the users to lightweight and clever organize the 3D model. And the other different modules of Reconstructor provide different kind of post-processing option for 3D scanning, job in engineering, construction, surveying, mining, and other different kind of application. There is also a set of easy to use tools which support the extraction of different kind of deliverables from 3D models, PDF reports, cross-section, movie, inspection, maps, orthophotos, and Reconstructor is also fully integrated with third-party software such as Autodesk, Recap, Edgewise, for scan to beam, micromine for mining analysis, and the Reconstructor project can be also easily distributed over the web by, for example, Magnet Collage Web, as Aizat mentioned before, Scene2, 3D UserNet. So you have a sort of end-to-end package that help you from the data import up to the sharing of the deliverables. I will leave now Aizat explain a little bit more about the deliverables that have been extracted thanks to Reconstructor capability from the data of the cave.
So, okay, this is the sample result that we have done from this expedition. So this shows how the Reconstructor software can extract the contour line, as we have this feature in the Reconstructor software. And this software contour algorithm where you no need to do the meshing before you generate the contour line. So you can set the starting elevation until the maximum height, and you can set the interval value to generate a contour line. After it generates, you can see the orthophoto view for every contour section and give an option to export the data in TIFF image file format or the export in AutoCAD format, AutoCAD script, as Giorgio mentioned just now. You can import into the AutoCAD in the scale 1:1 size. Yeah.
Thank you very much, Aizat. And yeah, this is one of the features that the user like, the possibility to extract the contours or even profile, isoline, generally speaking, cross-section. And let me jump to another features that I think has been useful. I will leave you explain this mesh creation. Let me see. Okay, just start the movie.
Yeah, this is show how the Reconstructor software generate a 3D mesh from the 3D point cloud data. It is a beautiful surface from the 3D point cloud data, as you can see. And now the software will generate a 3D mesh with a few settings. So before it can show the 3D mesh data. right?
Yes, it's
Yeah.
Yeah, no, sorry. Thanks. It's a nice tool, this one, because by these features you can create meshes from point cloud, and you have different way of mesh creation. This one is the so-called 3D mesh tool, which is pretty used in tunneling, in cave, for the capability also to create a close mesh, filling the gap. So thanks to have underlined also this capability. And I think that we have almost reached out to the end of today's webinar, but before moving to Q&A session, can we summarize some key points of this project for our attendees?
Yeah, we are at the end of the presentation. So in my conclusion, I would like to conclude that the 3D scanning provide the user with an extremely accurate measurement and the ability to fully utilize, visualize, and modify the data with CAD. Okay, the ability to rapidly capture high accurate information means vast saving in productivity and time, which is important, which of course it is important when delivering the result to the client. So this is very useful and educational to whom the approach a 3D laser scanner survey and the post-processing procedure for the first time who use it. Yeah.
Thanks a lot to have summarized, Isaac, the main conclusion of this project that we have seen has been pretty complex because different things have been considered, of course. And I think that now we really come to the end of today's presentation, but before leaving, we have some time for your questions. But first of all, I'd like to thanks pretty much Isaac and the Topcon team for bringing us into this project. And we do hope that this will be only the beginning to learn more about the mystery of the Biwo cave. So really, thank you very much. And please, Isaac, now remain with us because we do have some question. And so let's start with the question. Let me try to see if I can read them. Okay. There is a question for you. Yeah, it's both for me and you. For the HERON, were there any drift issue? And in case if they have been fixed in Reconstructor, I can reply on this. HERON does have a way, of course, to fix a possible drift issue that can occur when we talk about the SLAM technology, and this drift can be fixed, or generally we can say that the data can be optimized in HERON Desktop, because in HERON Desktop we do have two possibilities to use both the control points, any kind of control points, ground control points or target on the wall, or even already georeference scans, like for example the GLS can be used as a reference, as constraint, sorry. You can use so both control points or already georeference scan as constraint inside the HERON Desktop to optimize the HERON trajectory. So in this way, in a certain way, you do two jobs in one, because you can georeference the HERON data, but in the meantime, you can also optimize all the data, and so eventually fixing or adjusting some drift. The other question is for you, Isaac, is for the GLS, was backside georeferencing used did you use the backside georeferencing in this project?
Yes, we use georeferencing in this project. We just get it the coordinate outside of the cave by using GNSS product, and by then with the two control point we can start to carry all the coordinate go inside the cave. Yeah, at the same time we match with the cloud to cloud method to add some of the part that very hard to collect with the traverse method, occupy and base site method. Yeah. Yes, we use the coordinate.
Thanks, Isaac. I have another question for you, which is mainly related to the to all the project. Which kind of positioning accuracy were you achieving in the cave with both the system in real time and in the post processing?
So for the yes, of course, there's a for GLS you can achieve up to millimeter, as I tell in the slide. Okay, and of course for the HERON, when we integrate, we can achieve up to maybe 2 or 3 centimeter for the HERON data by referring the GLS-2200 as the reference.
Thanks a lot, Isaac. And another question for you. Did you use traverse directly with the GLS or with the total station?
We use using GLS-2000 for the traverse, since the GLS can do it occupy and base site, so we carry on the coordinate through the using GLS-2000.
Thanks a lot. And then what about the geolocation? I think that means, yeah, the general geolocation of the whole project. How did you manage the geolocalization? You mean the coordinates? I think so. I think so. It's a bit general question, but I think so. I think that it means the the geolocalization in terms of the complete coordinates of the project, how it has been managed. I think. Yeah. I think if I'm not, if my understanding is I use a GNSS to establish the control point outside, and we local coordinate to yeah. Yeah, and based on this, the HERON survey has been mounted. So they keep the GLS as a reference in terms of positioning, and then the HERON has been mounted. So Guy, thanks for your question. I have another one. Can I know if Topcon and HERON can do data classification? Okay, if it is possible to do a data classification, like for example, if it's possible to separate wall, trees, building, a sort of data classification. I think that this is mostly a software side. In terms of it is possible to classifying the part of the point cloud, creating, for example, creating some data classification in terms of trees, vegetation, point cloud, building, or something like that. Much more in this specific, it is possible, but in a semi-automatic way, not automatic. But please, Aizat, just also correct me if I am doing wrong or not.
Yes, I agree with that. Yeah.
Okay, then a question like how is the HERON's battery life? Well, HERON battery life, the standard battery is around 2 hours and a half. But of course, it is possible to use also what we call the high capacity battery that allows you to extend the battery life of HERON up to 5 hours, 5 hours and a half, more or less. And so you can cover all the daily work activity. Then, if it's possible to create a single point cloud merging GLS and HERON data, I can leave you reply on this, Aizat. If it's possible, to create only one single point cloud merging the GLS and the HERON data.
It means the combination between GLS and HERON data to become one file. Yes, it's possible to. Yes. We can make it in one file for the both point cloud data.
Okay, thank you very much. Yes, and it can be also export in different in most of the common open sharing format, E57, LAS, and so on. Then something more about the possibility to run also the looking at the difference between the two surveys. Yes, we have just mentioned briefly that it's possible not only to do what we call the mapping, but also to do a sort of monitoring of the differences of the site. And of course, it is possible to do this kind of analysis in two ways. In real time, because, for example, the GLS data, as well also as a BIM model, if you would like, for example, the differences between the as-built and the as-design. You can even use a BIM model. You can use this BIM model and the GLS scan, for example, as a reference inside the HERON solution. HERON can track its own position, just comparing the geometry, the features. When HERON has been tracked, it moves, and when you start moving, you can display in real time the differences. This is the first thing. The other thing is that it is possible also to do this kind of differences analysis in the post-processing, thanks to a feature that is provided by Reconstructor, which is called inspection or verification, by which you can compare models acquired in different times, or even a BIM model to carry on the as-built as design, or even, for example, to check for verticality and horizontality map. So it is possible in a certain way to do this kind of analysis of the differences in real time, and also in the post-processing. Then I do have another question, a lot, and we are happy, Aizat, because people are pretty interested. I think that we do have still 2 minutes. In your experience, what is the optimal distance between the static scan for a good accuracy working with HERON? So how we suggest to use the static scan, the distance of the static scan, I think that really depends on the survey that you are carried on. If you work in...
It means distance between every scan station?
Yeah, exactly. This is
that one
this is
is
my
depend on the how complex the structure is. Yes. So in my experience in this case, there's a time if is a large area, large area, and there's a flat surface, you can make it further from station. But if there's a lot of curve and there's a very complex structure, so we can recommend you to have a multiple station at that area.
I do agree. It really depends on the complexity of the site. Exactly. Then I think that we can have the last two questions, and then we will follow you up, guys. Can I use a reference as reference for HERON prism measure with the GLS? Yes, of course, not directly the prism, but of course you can measure the prism with the GLS, and we can use these coordinates, right?
Yeah.
Exactly. And this is also another point of synergy and integration between the two technology. And then I think the latest one, nice. People would like to know if you have carried on other survey using HERON in order to, especially in this kind of complex site, which has a lot of criticity in terms of accessibility and also complexity in terms of geometry and so on.
So far, we often use in structure, okay, to extract the 2D layout, elevation layout, and sometimes we use to do the volume calculation in the for one, and I think last time, we use for the I think one of tunnel to do the data calculation, to use a HERON.
Okay, many thanks. Many thanks, Aizat. Really, I think that we have come to the end. Thank you very much, first of all, to Aizat and the Topcon Positioning Malaysia for sharing this experience that has been pretty interesting. Thanks a lot also for all our attendees today. Thank you very much for your time, and we hope that this session has been useful to to make you more understanding about the integration of the technology, and also looking at a nice project in a very nice environment. Before leaving, don't forget to follow us through our channels, so that you can always update in terms of our event, activity, and news. If you are interested, of course, to know more about the Topcon and Gexcel product, feel free to contact us. And this movie will be also shortly uploaded on our HERON YouTube channel. And of course, you will receive also the recording of the webinar. So we look forward to seeing you in the next event. Thanks again for have been with us today, and thanks a lot also to Aizat. And we hope
Thank
to
you,
see you
Georgia and team, to arrange this, to organize this webinar. It's our pleasure to with you today.
Thank you very much. So enjoy all the rest of the day, and hope to see you soon again.
Okay, all right. Hope
Bye.
to see you too. Bye. Thank you, everyone.